Hello and welcome. My name is Clint. I'll be talking today about using large language model agents in behavioral experiments. This is a supplemental talk for a roundtable discussion at the meeting for the Society of Personality and Social Psychology in 2025. So if you're watching this video at a later date, just know that it might be outdated. And I'll mention that in the context we're using today, agent, which can mean a lot of different things, we're using to mean an entity that can take place in a social setting or experiment. And that'll manifest in a few different ways, which we'll talk about. So first I'll go over what I'll talk about today. Just a quick overview of why we would use LLMs in experiments. We'll go over a few things about data security and ethics. We'll talk about the problem design that we'll be using. And we'll talk about the software we're using, which will be Otri. Okay, so why would you use large language models in behavioral experiments? The first point I could make is to simulate agents that can be from a lot of different contexts. So this you can kind of simulate a persona that the bot will take place from, various cultures, various personality characteristics, and things like that. It can also be used in a standardized way. So if you compare it to, say, a human confederate in an experiment, you can have the agent be fairly deterministic, such that every time you ask it the same thing, it'll give you the same answer, which is useful if you're, let's say you're doing something like an education intervention where you're teaching somebody how to code or something. You would want the agent who is training the human to be very consistent from participant to participant, which might not always be the case with a human. You can also study human AI cooperative tasks. So as it relates to things like the future of work, the future of education, I think this will be a growing concern in society. So just as an example, Pew Research Center reported that 26% of US teens have used ChatGPT for their homework, which is up from 13% in 2023. So I believe this is a technology that isn't going away. It's going to become more ubiquitous in society. So it'll be important for social psychologists to study, I believe. Just a few things about data security and ethics. If you'll be using commercial large language models like things from OpenAI, Anthropic, Google, the most important thing I think you could do is inform participants how their data will be used. So, for instance, if you go to OpenAI's policies online, they say they'll keep the data for a maximum of 30 days. But they may keep it longer than that through de-identification, anonymization, and aggregation. So I think the most important thing you should do is just communicate this to participants at some point in the informed consent process. Okay. And you should also reduce the risk of personally identifiable information being disclosed by the participant. I think you can simply just ask the participant to not do this. So this would be things like their name, where they live, anything that could be kind of traced back to them. We'll talk a little bit about vocal data later, which is also identifiable, but there are more sophisticated kind of software things you could do to redact information that the participant discloses before it ever gets sent to like a commercial large language model service, but I don't think that'll be really necessary for most of what we would be doing. So just kind of training the participant to be mindful of good data hygiene. Okay, I'm not sure how much research has been done on this, but we'll also be talking about using agents to mimic a human from certain backgrounds. So for instance, I do stuff with politics. If you have an agent acting as a political conservative, the agent might display certain characteristics that are stereotypical. And you wouldn't want to have the participant leave with a more biased attitude of a certain group at the end of the experiment. So being thoughtful about debriefing, the the characteristics of the agent that they interacted with might not necessarily be indicative of how that group behaves. It's a simulation. So just sort of like disclosing something like that in the debrief, I think, would be prudent. And finally, there's a lot of other ethical considerations around using large language models, things like energy consumption during the training process, and also things like who is sitting on the board of some of these companies. I think these are things to be mindful of, but perhaps outside the scope of this video today. So I just wanted to bring it up in case you wanted to think about that. Okay, so the prompt design that we'll be using, I'll just go over a few of the important structural elements. We won't be talking about prompting as if you were like using a web interface. We'll be using the API, the application programming interface. So we'll be setting up our agent through code, basically. So to start with, I'll go over the system prompt. So this is just an instruction. You think of it as a manual for how the agent is going to behave and what rules they will follow. This sort of happens behind the scenes if you were to use one of these services like online. They'll have some kind of system prompt behind the scenes before you have the conversation. So we're kind of going to do that too and use that to have the agent adopt some sort of personality. So here's a simple example. You are Alex, a human participant taking place in an online discussion. Always limit your messages to less than 200 characters. Speak in an informal language. So we give it a name. We give the bot a few rules to follow. And the messages that will be sent back to the participant will be constrained by this system prompt. So the next structural element is the user prompt, or I should say the messages sent by the user role. And these are just what the participant says back to the agent through the software. So it could, as you might have chatted with the LLM service before, it could just be like questions or comments, things like that. And then finally, the messages sent by the assistant role are, again, the LLM agent, and it sends messages back constrained by what we said in the prompt. So, we told the agent that it's a human participant, so it's not going to act like it's a robot or animal or the moon or something. So the structure of the whole conversation follows something like this. You have the system prompt, and then you have the user prompt, and then in most cases, which we'll talk about later, this will prompt the assistant message, and then the user will send another message, and so on and so forth. And then the entire conversation, the way we have it set up, is going to be sent to the service every time a new message is added, and that's how it sort of incrementally decides to add a new conversation messages. So the whole conversation gets sent to the service, and it grows every time you have a new message. Okay. And I also wanted to go over structured output. So this allows more control over the assistant message. So imagine, if you will, for the assistant prompt, we want to embed not just the text that the agent is sending back to us, but some other information that might be helpful, like let's say the tone or accent that the agent is speaking in. It could have some kind of decision that we program it to make. It could have some sort of metadata, things like timestamp, or we'll be talking a little bit about reactions to messages. that we can embed in the conversation. So this is just sort of if you wanted a nested structure with more information, and that sort of just opens up for us to do a lot more creative things in a conversation, and that'll be clear later on when we walk through some of the code. All right, just a couple other factors we'll talk about. The first is temperature. So this determines how deterministic the model will behave. So this typically ranges from 0 to 2 for most models. Very low temperature will be deterministic, such that if you give it the same question, it'll give you the same answer. So this is really helpful for things like coding or something like very factual based. If you don't want a lot of variability in the response, you would want to set a low temperature. Higher temperatures, like above 1, will be more random, more creative. So if you have an agent that someone is conversing with that has a lot of variability in their responses, you would want the temperature a little bit higher. In past experiments I've run, I've just set it at 1, and that's pretty good. But you could I would encourage you with any of these things to play around with the prompting and kind of see how it meets your needs. The next concept is tokenization. So this is how the text is quantified by the service. So language is broken up into smaller tokens. So low-word psychology might be broken up into like psych and ology. And that's sort of how the language model processes the length of what you're sending. So and it's also how you get charged. So you're charged by the token by these services. So the longer chat, the longer text that you have, the more processing it'll do, and the more it'll charge you per request. And then model versions, rate limits. So for more complex models like GPT-4, these can be a little bit more slow and also cost a little more. So you might run into situations where the service is getting hammered, and if you're running like 200 participants at a time or something, then everybody's hitting the server at the same time, and the model just might not keep up with it at the same time. So just something to keep in mind of with like the simpler, more conservative models, which I think are very good. You probably won't run into things like that, but you might want a more sophisticated model if you're doing something that requires it. So okay. So the software we'll be using is called Otree. This was developed as a platform for running experimental economic studies, specifically ones that are multiplayer in nature. If you ever heard the software Ztree, Otree was sort of made as a spiritual successor to this. So things like public goods games, trust games, things like that. That's kind of what it really excels at. The platform itself is built with a Python backend, and you have a lot of flexibility using the web interface as well. So you can do very sophisticated interactive sort of experiences for your participants, which is one of the reasons I favor it most. And then, also if you wanted to embed humans, like multiple human players in an experiment, it's really great for that. The infrastructure is in place. I believe it used to be based on Django, if you're familiar with web development, but now they have their sort of a custom kind of platform that's similar. So there is a little bit of coding involved, but with the templates I'm providing, I'm hoping that it'll be easy to just sort of tweak what we have and meet your needs, which I'm also happy to help with. So we'll move over to the software side of things. Okay. So we'll be downloading a few software things we'll be needing to get started. So here is a GitHub repository that I put together along with some templates that will hopefully you can tweak to meet the needs of your experiments that you're running. We'll be going through these in a minute. If you want, you can download it as a zip and put it wherever you want to work from, or we'll use the terminal in a minute to just download it. You also need Git if you do not have it. This is for interacting with things like GitHub. You also need a version of Python if you do not already have it. When you're installing this, make sure to add, there should be a checkbox that says add to path. We'll need that to interact with it in the terminal. You also need the GitHub command line interface if you'll be using GitHub. So this just allows us to interact with GitHub. You also need the command line interface for Heroku. Heroku is a service that you use to host websites and apps on the web. So we're essentially going to be wrapping up a website and hosting it on Heroku for as long as we'll be running participants. And then once we're done, we could just take it down. And then finally, for whatever commercial LLM software you'll be using, you'll need to get an API key from them. In this case, I'm just going to use OpenAI. The API key will usually be something like sk dash dot 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 something. So we'll be using environment variables just to reference our API key. You can also just paste this into the code if you want to, just for testing, but I'll add it to the Windows environment. So you could just hit the Windows key and type environment, and you'll see edit the system environment variables. We'll click on this button at the bottom. It says environment variables. And down here, we will add a new one. We'll call it OpenAI key, and then we'll paste in our API key here. With that all set up, I'm also using, as I'm in Windows, a custom terminal called cmder, which you can get if you're interested. I was having some trouble with PowerShell, so this is one that I often use in Windows. So if we go back here to the GitHub repository, we can click on code and copy this URL ending in .git, and then go to our terminal and type in git clone the URL, and it'll download it for us. Great, and then we can change directories into it with cd, poetry, GPT. Okay, and then we're going to set up a virtual environment, which will help us just sort of insulate all our packages that we'll be using. We'll do python -m venv venv, and then we will activate it with /venv scripts activate. Oh, there we go. No slash at the beginning. All right, great. So what we're going to do is install all the Python code packages that we'll be needing. So if I open it up, since we have it downloaded, we can open it up in a code editor. I've been using this one called Windsurf recently because it has some nice AI tools that sort of help me with tweaking things in my code. Yes, I trust Clint. Okay, and then so here we have all our files. And there is a terminal in this that you could use. I just often use a separate one. So if you look in requirements.txt, this shows us the packages that we'll need to use. which include Otri. Bodo is for Amazon S3, which we'll be talking about in a minute. Pydantic is for validating some of our structured output that we talked about. OpenAI and requests are for sending requests for these API services. So to install this, we go pip install -r requirements.txt. And it should get us all the packages that we'll be needing. Okay. And just a quick note, I originally had an older version of Otri here that I was using. I took that out, and it should work with Python 3.12. So we'll be using, so now that that's all installed, if you want, we can run a local development server with Otri dev server. And in a new window, localhost 8000. Let's see if this works. Yeah, there it is. Okay. So when you're just testing your code locally on Otri, you can go through your experiments, and there's different tabs up here at the top. So demo is where you can click on the different applications you have to test out. I won't go through a whole tutorial on Otri, but there's plenty out there that are great for you to check out. So we'll mostly use demo, and then once we're on Heroku, we'll use rooms and data to sort of check that out. All right, so the first template I have is chat simple. This is just a really simple application. Go back to the code here. Within each application, we have a folder, and in that folder, we have chat.html, which is the code that for all the HTML side where the user sees, or the participant. We have page.html, which has a lot of the styling. I kind of put a styling file in each application, but you could do it at the global level if you want to. And then this initpy, which has all the server information. So the important things to focus on here are we have this constants grouping here, which has some information that I just preset. So we're going to call the bot. We're going to have it at a temperature of 1. We're going to get our API key from the environment variables we set up. Again, if you want, you could just paste it in here to test out and make sure it's working. The model we're using is GPT-4o Mini, which is a good, like, simple model for interacting with agents. It's not, if you don't need to do anything too complex, like, physics, and it'll be fine. Okay. And then we have here 2 different system prompts. So the way this experiment is going to work, we're just going to randomize these 2 things. So for this Republican prompt, we're going to say, oh, you're a small business owner, you are participating in a gun control discussion, and you are maintaining conservative viewpoints. You're concerned about the Second Amendment. So you're generally supportive of gun rights. And then we have this Democrat prompt, which is similar, but it is an urban school teacher. They are maybe have some kind of experience with gun violence in urban setting, focus on policy measures to reduce gun violence, so a little more pro-gun control in this case. And so what we're just going to do is randomize participant to view either of these 2 bots. So we have this function here that I'm using in pretty much all of them called runGPT. All I'm doing is wrapping up a request to the OpenAI service, and then in this case, I'm outputting just the text response. So if all you care about is having participants chat with a bot, seeing their text response, you can use this as sort of a template to do that. In the creating session function down here, basically when you start an experiment, when you set it up, it'll run through this code for all the participants that as many as you say you want to have. So in this case, I just have 2 conditions here in a list, and it's just going to randomly choose one of them and assign that based on the system prompt that we set above. And then we're going to assign that to the participant bot party variable, which is down here. And then also in this player variable, we're going to have all the messages saved. So this will make a little more sense when I show you the data output. Okay. And then Otree also has this function for called extra models. So if you have a lot of information that doesn't make sense in like a single player variable, but like maybe a longitudinal thing where you have a lot of data points over the course of time, you could sort of make records using this format. So each time we send a message, we're going to send the bot party, so which sort of prompt the user was assigned to. We're also going to have a message ID, a timestamp, a sender, which is always going to be the bot or the user in this simple example. And then we're going to have the text information as well. So that's just basically getting a long format data frame that we're going to be able to do with this export function. So basically, it's going to iterate through all of those messages that are recorded during the course of the experiment, and we could easily export them afterwards. Okay. So we basically have one page in this template. I have the timeout set to 300 seconds. Yeah, so that'll be a few minutes. There's a few functions that Otree has to pass from the server to the client. So when I say client, I mean what the participant's web page is looking at, and all the code that's running locally on their laptop, computer, whatever it might be. And there's also this live method, which allows for kind of synchronous communication between the two. So basically what we're going to do is we're going to have the client send a message to the server. The server is going to run the LLM and then send it back to the client, and so on and so forth. And that's sort of what's happening here. And if you would like, I can go through a more detailed walkthrough of all this code. But basically, if we're getting text from the client, it means that the user types something in, sent it to the server. So we're going to create a message here. We're going to append it to the list of messages of the entire conversation, and send it back to the server where it's just rendered in the chat log, and then that's going to trigger another server event called bot message, which will, depending on the class of the bot, we're going to run LLM, run the whole conversation through the LLM service, and then it'll spit back something that we basically what the reply would be. Okay. So let's see what that looks like. We have the chat simple. We're just going to open this. Okay, so you see it was assigned. It assigned us a Democrat just randomly. So we can say hello, assuming the environment variables are correctly set up. It should be able to run with internet connection through the OpenAI service. Okay. And I'm not the greatest like user designer, so this is just I put this together to sort of you could kind of tweak like the stylings and stuff of what the interface looks like. So if I wanted to argue with the bot, it might try to persuade me that gun control is good. That's what it says. Yeah, so it's trying to be respectful, but sort of trying to find common ground as well. So, and then if we make a new one, we could kind of see if it gives us a Republican this time. Just gonna run this again. Yeah, here we go. Okay. Great. So it sort of comes from a Republican angle. So you can imagine how you can randomize a participant to interact with various different bots from different backgrounds besides politics. That just happens to be what I'm interested in. But and you'll also notice that the styling was red if it's a Republican, blue if it's Democrat. So it kind of like hammers that home. I have that set up here in the styling page .html here at the bottom, I think. No. Where do I have it? This is all the CSS that I have. So we have, maybe it's in the other one. Maybe it's just here. Well, I pass in this bot class, and basically if it is blue text or red text, depending on if it's Republican or Democrat, respectively. Where is that? Yeah, so here I have the background color and the for the span, which is like this over here, to be red if it's a Republican bot and blue if it's a not Republican bot. Okay, so that's that. So let's go to the complex example. So if you think back to what I was talking about, nesting information within the assistant prompt, this is sort of what we're looking at. So it's going to be similar to what we just looked at, but we're going to embed these emoji reactions. So we'll be able to react to different messages that the bot sends or our own messages if we want. And in this case, for our system prompt, we're going to ask the prompt to give an output that is structured in nature. So we're going to ask it not just the LLM to return just the text that we care about, but actually a dictionary of information. So as an input, we're going to send a JSON or a dictionary object that has the sender, which is just the user, a message identifier, which is sort of an ID for the message that's being sent, just to keep track of it for data purposes. Instructions for responding, the tone, so we're going to vary the tone that we'll use, the text that they'll be responding to, and then we'll also have the reactions that are passed to them, which I've had mixed results trying to get the bot to sort of understand that past messages that we've reacted to, getting it to sort of acknowledge those and change its behavior based on those. But maybe you have more luck with that. And basically, these emojis that I put up here can be changed to or added on if you want, and it'll just make up. Let's see, put like a cat or something. Okay. All right, and that should we should be able to see that in the application. Okay. So like I said, as output, it's going to give us the sender, the message ID, the tone it's using, the text, and then all the reactions, which will be blank when it sends it back because we're going to react to it after it sends the message. But then when we send the entire conversation back to the LLM service, it'll include reactions that we've embedded into the past messages, if that makes sense. Okay. So something really cool about LLMs and their development in the last couple of years is now they have these message schemas you can make. So if you want structured output, we can specify exactly what that will look like. So in this case, all of these fields that I want it to give back to me are going to be strings. We'll show an example with other types of data in the future. So you'll see this function is now a little more complicated. We're going to input both the user's text, like question or whatever, and then also tone. So from the constants, we're just using the same temperature. Again, you could vary this if you want. We're using the same label, same system prompt. And then we're going to make a timestamp here of the time that it was sent at a UTC timecode. So the reason you do that is if you have, like, let's say you have 2 human players in an experiment in different time zones, you don't want to get that mixed up. So just having it at UTC eliminates that. And then I'm just making a message ID from the bot label. So it'll just be like bot dash the time code, just for easy to reference in our code. And then it's going to give back this this dictionary, one of which this reactions field is going to be a nested dictionary. So text will be something like, hello, how are you doing? Tone will be like friendly, but this will be actually like the emoji for each one will be like who sent it, when they sent it, that sort of thing, the count. Okay. And then slight different to the OpenAI function here. Instead, we're using this parameters here to say we want to use this particular schema in our message response. And then let's see, creating sessions. We have friendly, so it's going to randomly assign us one of these. We could, for instance, make it like, instead of friendly, like sarcastic or unhinged or something. So I'll just do that. So that tone will be assigned to the player variable here. And then most of this looks similar to the last experiment, with the exception of we now have an event for reactions. So this goes through and if there's an existing reaction, it doesn't so the player can't leave just like 20 thumbs up or something. It'll just check to see if there's an existing reaction. If not, it'll add it to the message. So that's saved. All right. Okay. So let's see. Okay. And I also have it programmatically. It will tell us what tone the bot is over here. So we got sarcastic. Oh, well, grand entrance. Hello to you too. And you could, if you want, you could have it like something like tone or whatever it might be. You can get these features to randomize like for every message if you want, not just every not just every conversation. Yeah. So let's see if we could get an unhinged one. No, that's okay. Well, as you can see, the emojis here, we can react to different things, including ones we just like added, like the cat. And if we try to add more, it doesn't let us do that. And okay, so if you go to data, you could look at what this looks like. I'm going to open it with Office, with Excel, or whatever it might be. I don't have Excel on this computer right now, so. Okay, so in a spreadsheet, it will be like a long format, depending on the session. So I did like 2 sessions. We'll see, the sender, the tone, the timestamp, and then the full text, which is just sort of what was sent to the server. So if you can think back to the figure I showed you at the beginning of like the system, this assistant message, user message, so on, sort of looked like this. The message text, which is just literally what was sent, and then the reaction data. So for here, we don't have any reactions, but for the last one, we have the sender, the message reaction, timestamp, which emoji that was, which is a Unicode here, which doesn't show up in LibreOffice, but if you Google it, this one will be like, I think, the cat. Yeah, the cat one. So there you go. So that's an easy way to tell like when emojis were sent by who and which emoji it was. Okay. So the next one we're going to look at is it voice or dictator? Yeah, we'll go voice first, which I think is kind of interesting. So it's going to look very simple or very similar to the Chat Complex app. You can have a text transcript if you want. You can have, emoji reactions if you want. In this case, what we're doing is having the server record the user's microphone audio, transcribe it, send it to the LLM service as a text, send the LLM's response back as a text, and then create an audio file of the LLM's response in a text-to-speech service. So we'll be using ElevenLabs, which has like a ton of different like really impressive virtual voices that you could use. It's a little expensive, but there's other ones I'm sure you can wrap up if you want. So the reason I have Amazon S3 here is because to securely store the vocal data, which at least where I went to grad school, they considered it personally identifiable information. You don't want to have it on the server that we're hosting. You would want to save it somewhere secure, like a S3 bucket. If you're just doing this in a lab, like your computer lab at your university, it should be fine to just save locally. So I'll just leave that at false for now. But if you're using this online on Heroku or something, you would definitely want to set up a S3 bucket so you're not exposing files out there. Okay. So you'll just need to set this up, get a API key from ElevenLabs, and if you want to use this one, and then also find a voice that you want. This is a nice British female voice that I'm using here, and this will be passed to the text-to-speech function we have here, which we'll be using the request Python package and just doing it through like their web URL. Okay. And everything else. Oh, if you want to set up Amazon S3, you'll need to get the S3 key and secret, and also save that to your environment variables, or if you want to just paste it up there to test it. And then it'll save in the bucket that you determine. Where's the bucket? Message. And then we specify the bucket name down here. If we're saving it to Amazon. In this case, I should put this as a constant so you could change it more easily, but I just named my bucket otree-gpt. If it's not saving to S3, we're going to just save it to the static folder up here. Okay. So let's test this out. Chat voice. We're going to try the chat voice application here. The way this works is I will press the spacebar to trigger recording from the participant microphone, and then tapping it again will end the recording, save it to the server, make a transcript of the data, send that transcript to the LLM service, and send back the saved audio from ElevenLabs. So we'll try this. Hello, how are you today?
Hey, I'm doing great. Thanks for asking. How about you?
So you can see this is, you can do something interesting like randomize what sort of accent somebody has, how they speak. You can change the tone of the voice in ElevenLabs by going down. The way they do it is, in my case, I'm just keeping it friendly. But when you send it to ElevenLabs down here, where is it? You would basically have less than, like, friendly, greater than, colon, and then the message. So that's sort of how it's getting read through the ElevenLabs API. But if you're using some other kind of text-to-speech thing, then it would probably be different. And what's really cool about this is you can actually just change languages on the fly. So, like, ¿Dónde está la biblioteca?
La biblioteca está cerca del parque, al lado del café. Buena suerte.
O genki desu ka?
Oyuanti desu ka kintiani wen ite kurete arigato.
I'm not sure how good these accents are, but you can see how this could be really cool for, like, cross-cultural research, or if you're trying to study how people acquire new languages, how, you could practice a second language, that sort of thing. So I think there's a lot of really interesting things you could do with voice that hasn't been done yet in our field. Okay. And I'll mention that if you're not set it up to ElevenLabs, this will get just saved in this global static folder under chat voice /recordings. So you can kind of see here how it's saving the bot ones as MP3, the local ones as WebM, just because that's easier to do in the code. Okay. Next application we'll be going over is a Dictator game. So you'll just be playing a Dictator game with the agent. And based on the output, the agent's going to give back a perception difference. We're going to have a perception rating of how trustworthy the human is. The trust rating, which is what the new updated trust rating is, and then the decision whether or not to trust the human. So as you'll see in our message schema here, instead of all strings, we have the perception difference is now an integer, the trust rating is also an integer, and the decision is a Boolean, so that just means true or false. Okay, so in our instructions that we embed within the runGPT function, we're going to have it be, the perception difference is going to be an integer ranging from -5 to +5, based on how trustworthy you think the user is being. So if we say something trustworthy, ideally the trust rating should increase, which is just an integer sum of the last trust rating that is passed through. And if we say something like not trustworthy, it should decrease. So we set up the initial trust rating just as a somewhere based on a random distribution around 50. And in this case, I have it somewhere between 40 and 50. And then pass that to the player model. And then the decision, again, is just a Boolean true or false. If you wanted to have a humans participant playing with a LLM agent in some kind of economic game, you could have it like as a split decision, like an integer. You're splitting some amount of points or some amount of money. You could also have it as like a dichotomous Boolean outcome, which is just like, did they trust or did they not trust? And that's sort of what these two are meant to represent. Okay. Let's see here. We have the trust rating, and this just gets updated based on the new perception that is what the LLM perceives the human participant's input to be. And then this new trust rating is turned into a probability. So in this case, we're kind of treating this as like a function in Python that we're using in collaboration with the LLM output, which is just the perception difference. So you could just ask the LLM bot to come up with a new trust rating based on something, but I thought this was interesting to showcase just how you could do, some sort of statistical methods and combine that with what the LLM agent is saying. So in this case, we're just taking the new trust rating out of 100 and treating it as a probability. And basically, if there is a random, we sort of generate a random number, and if it's less than that, the probability, the new decision is to trust. Otherwise, it's to not trust. So the higher the trust rating, obviously, the greater likelihood will be that the bot trusts us. Okay, so I'll show you what that looks like. So similar to the chat complex, we're just going to have the trust rating up here, and it was set at 50. So we'll try to get trust us. LLMs are pretty good with misspellings. Okay, so it didn't change at all. Good person. Oops. Okay, so let's try this out. So hello. CCO was sampled to be 48 for the trust rating. Can totally trust me. I am a good person. So it actually went down. So trust takes time to build. What makes you a good person? I could try to intentionally make it go down by being like, I don't like LLM bots. Oh, actually, so it's kind of strange that it responded positively to that. But, I to lie in conversations. It didn't change, so yeah. So basically, when the thing is done, the final trust rating was where it started, 48, and then based on the probability function we showed you, it decided not to trust me. So this is an example of how you could do just simple like economic experiments with LLM agents. Okay, so the next one we'll do is multiple agents. So this one is maybe the most tricky one I had. So in all our cases, we based the agents triggering a response based on the human participant sending a response first. That doesn't work if you want to have multiple different agents in one conversation. So in this case, I'm sending a trigger every few seconds for it to check whether or not the participant has said a response, and then based on that, we'll send a LLM agent response. So if we look here, we'll have two bots, so a participant bot and a moderator bot. So what I'm doing in here is just treating the bot as let's say, a student in social psychology who is in a debate about cognitive dissonance versus self-perception theory. You take the place of cognitive dissonance. And then we also have a moderator bot here who is moderating this, and we have some instructions for how to improve the conversation, possibly. So the moderator bot chimes in every few messages the participant bot will chime in after every message that is sent, if that makes sense. So first they should send a greeting. Excited to begin the discussion. Hello everyone, excited to moderate. Okay, who'd like to start? I love self-perception theory. Sorry about the misspellings. I also have it tell it to like make citations and everything. Think about the role of arousal. Anna Cooper, yeah. And so now that there's been a few messages, the moderator bot chimes in and suggests, oh, we can benefit from a more structured approach. Consider examples. That's not that helpful, but if you can try prompting and changing the instructions to the moderator bot to be more helpful. I think this sort of thing would be good if you're doing like a debate between different political backgrounds, that sort of thing. You could also have, I used a moderator bot, but it could just be like another participant. It could be whatever you want. So, yeah, so that is the multiple agent chat. And then the last one I'll show you is threejs. So threejs is a JavaScript platform for building 3D environments. I thought it would be interesting to show how the LLM bots responses are triggered not just by time or by sending a message to them, but by something else like physical distance in a virtual space. So in this case, I have 3 bots, red, black, and green. I have them in various starting positions. You can also make them move around if you are so inclined. And they all have very similar system prompts, but in my case, the task of the participant is to try to figure out what happened in a crime, and each of these bots are like a eyewitness, and so they have different information that you have to piece together by talking to all of them. So like the green bot saw the time, but they didn't see if it was a man or a woman. They didn't see if they had an accomplice, that sort of thing. So let's see here. Okay, so you can move around with the arrow keys, and you can talk to the bot, which is just at the bottom there. Okay, I saw a guy with mustache leave in a blue vehicle with a female driver. That's pretty helpful. And you, kind of vehicle. I saw somebody, so they saw a truck, and it was after 5:30. Okay, what about the vehicle? So they don't have access to the other agent's information. So he's not helpful about the vehicle, but he was able to tell you the the person was wearing glasses. So and I'll just show you the way this is working. I have a debug mode. So if we set this to true, you kind of see what the over here on the left, we have the distance to the different agents. So if it's within 10, it should trigger a LLM response. So because I'm 12, it isn't, but if I get closer, hello. Yeah, okay. So it only triggers if you are within 10 units of the other agents. And obviously, you could change that to however you want. This is just one example. You can also, I thought something like this might be good for like a jigsaw classroom sort of thing where you need information from different sources, possibly from different valenced attitude, objects, people, agents, that sort of thing. I thought it also might be good for something like a cyberball paradigm where they're like avoiding you. One of the original examples I had was the agents just like running away from you wherever you're trying to be, and then were kind of rude to you if they were talking to you. So there's a lot of things you could do with a virtual 3D space. You could test out like an agent-based model and embed a human in that and just see how they behave, and that's like a grid or whatever it might be, that sort of thing, or just like make like a video game and sort of just see people's curiosity spread. So that is that. I'll show you real quick the data tab. So these are all the ones that we went through. Like for the most recent one, let's see what I have. Okay. I see the message ID, timestamp, tone. You could see kind of what all the text that we had seen from. I have the reaction data here, but it's not actually logged. And I thought I had position data in here. I guess I don't. I think it might be under. So this custom data is for the custom export is for those extra models that we made. If you look at just the threejs data, do I have it here? This is more the normal data. I guess I don't have it here. I'll try to implement that in a future release, just so you could kind of see like where participants are moving around and where the agents are moving around. I'm pretty sure I do log that somewhere, but it is not here. So the last thing I'll show you to do is we'll set up a Heroku application, and this will be to host the service online for remote participants. So we'll create a new app. Just call it SPSP 25. Common runtime, create app. Okay. And then, so it'll give some instructions here, but assuming that we have the, oh yeah, here's the position data. Assuming we have the everything in place, we will the Heroku CLI in place. We should be able to log in here. Did I install it? Okay. So bring up this. Just log in here. Okay, we can close that and go back. Great, it should be logged in. So then we're going to, we're already in our project, so we're just going to initialize. It should be initialized. We're going to add here. Okay. And git add, git commit, initial commit, or make it better, whatever they say. And then git push Heroku master or main. Failed to push some refs. Okay, master. Yeah. I don't know why it says main. Okay, so it looks like our build succeeded. So we'll just need to add a couple services to Heroku. The first thing we'll add is the web dyno. Depending on how many participants you're running and the complexity of your study, you might need to go to a standard. We'll just keep it at basic for now. And we will turn that on. And so this is how much it costs, which is about $7 a month max. Of course, you probably won't be leaving it on for a month. What I do basically is just leave it on while I'm running participants, and then turn it off afterwards. And so the other add-on we'll need is Postgres, Heroku Postgres. So we'll just do essential one. And this is the sort of database where the data is stored. So we have sort of like the processing side and then the database, and it just takes a couple minutes to provision. So we'll wait for that. Okay, once it's done provisioning, we can open the application here. And you'll see this is just like what we had on our local machine when we ran O3 dev server. But if we go to server check, we'll have, the debug mode is on. So we'll want to change this. And we also want to change the password. So we set the password, but we did not do O3 auth level. So we're going to do O3 auth level equal to 1, I think. Yeah. And then O3 production equals, I think, 1 as well. Yeah. And that's how you set environment variables in O3. So we'll also set what we're using, the OpenAI key, and then we'll paste in the key here. Okay, and then once those are set, we will try opening this again. Okay. So we have something. Oh, we should do Roku run O3 reset DB, and this will just reset the server. Reset the database, I should say, on the server. Yes. Okay. And then we could also open it using Heroku Open. Application error. Why is this? Oh, you know what? I think I set this to 1, but it should be study, I think. Auth level. No. Auth level. Study. Let me try this. Yeah, okay. Admin password is undefined, so temp password. I guess we may have to do that afterward. Oh, invalid. Must be in the time foo equals power. Oh, whoops. So we'll just set the admin password like this. Okay. And then login will be, we'll just refresh, make sure that error goes away. All right. Login will be admin, and then temp password 3. Yep. And then here we go. And so this just prevents other people from logging into your server and grabbing your data or whatever. So if you want, you could test out everything here. Just make sure it works. We set up the environment variables for the OpenAI, so it should work perfectly. So we're not running on our computer. We're running it on a website that our participants can access from Prolific or mTurk or wherever you want to do it. So if we go to server check, we should see, we could go to the newer O3, but that's fine. But all this stuff is good. So I'll show you the way I typically run participants. I'll do rooms. I have a study room set up here, which you could specify in your settings tab. You could add more if you want to have like more studies running at once. So we click on the study room and then we say whatever app we want to use. So we'll do, I don't know, check complex, enter the number of participants. I usually oversample in case there's like dropouts or something. So let's say 200, whatever it might be. It'll take a second to configure. And then here is the URL that you can use to give to participants to participate in your experiment. And what this will do is open up a new tab with a specific participant ID, and you could link that up with this participant if you want to add on like another O-Tree survey or application, or redirect it to Qualtrics or whatever you might want to do. So you can also monitor participants as they come in on O-Tree. So you could see the tab I just opened was this participant, and they're on the chat page, and they were on for 7 minutes. That doesn't sound right. I think that might not be right, but you can access the data for this. I wouldn't click this during the experiment because sometimes it slows down depending on how complex the experiment is, it could slow down the user experience. But you can also get the data export from up here, just like we did locally. And then if you go back to rooms, you go back to the active session, and go to links. Basically this URL you can also append with a unique identifier, which let me make sure O-Tree does this. And label. Make sure I got this right. Yeah, so if you want to append it with like a prolific ID, you could do participant label equals whatever it is, and then you'll be able to identify that in the data when you export it. Sorry, just real quick, I will mention that once you're done running participants, as I do it, I'll just delete the things that cost money on Heroku, like turn this dyno off, and delete the Postgres add-on. And then you should see $0 an hour, $0 an hour. So it come out to a 0 monthly cost. So running for a day or two will probably be like, I don't know, a few bucks depending on the dyno type and the Postgres level you're using. And then once you're done, you could just be done. So, it'll probably, I think in past experiments I run with this sort of methodology, the LLM costs were a few dollars, the Heroku costs were a few dollars, so it was like $10 total for one experiment. If you're using ElevenLabs, it might come out to a little more because I know the API can be expensive, but it's an impressive service though, so it's kind of a trade-off. So, but yeah, I just want to show that real quick. So thanks, and let me know if you run into any problems. I know it can be a little daunting doing all this yourself instead of having like a service set up for you. If I can figure this out, I believe that you are capable of doing this. You're definitely smarter than you realize, I think, most people. So good luck, and feel free to get in touch with me if you run into any hurdles. I'll leave contact information below in the episode notes, and also a link to the Discord where you can chat with myself and others to try to get help, or I'd love to just hear about what you're interested in doing with this sort of research. I think it's really exciting and will be important in the coming years to understand how humans interact with LLM agents. So thanks, and have a great day.